Electrolysis is the flow of electrical current in a conducting solution or molten liquid that causes chemical changes. The conducting liquid is called an electrolyte and has free moving ions. The conducting plates, bars or wires inserted into an electrolyte are called electrodes. Positive ions are called cations and are attracted to the cathode. Negative ions are called anions and are attracted to the anode. When current flows in an electrolyte, it is the ions that move and carry the electrical charge. When current flows in the electrodes and wires, it is the electrons that move.
Okay, so key things to remember about electrolysis. First of all, the electrolyte has to either be molten or dissolved in water. This is because the ions have to be able to move in order for current to be carried. The ions are charged, and a flow of charge is an electrical current.
Lead bromide is a solid at room temperature. Before performing electrolysis, we first need to melt the lead bromide by heating it in a crucible with a Bunsen burner. Here you can see molten lead bromide. The two graphite electrodes are connected to a power supply with a voltage set to 12 volts. As the current passes through the circuit, the lead bromide is broken down into lead and bromine. Here you can clearly see the formation of orange bromine vapour. Bromine is normally a liquid at room temperature, but because the liquid lead bromide is at such a high temperature, vapour is formed immediately. After the crucible is cooled, we can remove the lead bromide and we can see the lead clearly visible in the bottom of the crucible.
So when you watch the animations that follow, you'll see that the lead bromide, because it's molten, is only made out of lead and bromide ions. So the only products can be lead and bromine. All metals make positive ions, so they'll be attracted to the negative electrode, and all non-metals make negative ions, so the bromine will be produced at the positive electrode. So let's explain what has to happen for the lead ions to become lead atoms. The lead ions are positive and are attracted to the negative electrode. At the negative electrode, each lead ion must gain electrons to cancel out its positive charge so it can turn back into metallic atoms of lead. Lead ions are 2+, so they need to gain 2 negative electrons to cancel out that charge. Watch the next animation. Now let's do the same, explaining what happens to the bromine. The bromide ions are negatively charged. When they get to the positive electrode, they need to give up the electron that is causing them to be negatively charged and turn back into bromine atoms. Then 2 bromine atoms join together to make a Br2 bromine molecule. Hopefully this has been helpful for you to explain what happens when a molten substance has an electrical current pass through it. Electrolysis has to happen in a situation where ions can move. We've looked at when substances have been melted, but we can also allow ions to move when substances are soluble and dissolved in water. The next video will be about electrolysis in solutions.